పేపర్లో పోవాలంటే ఇందులోనేనా వెయిటేజ్ వాడాలి. Good afternoon, all of you. The last class we completed vapor prayer of liquid in liquid and vapor prayer of solid in liquid we done. So today write date and write today we will discuss colligative properties. In the last class we completed vapor prayer of liquid in liquid and vapor prayer of solid in liquid, no? So today our discussion will be on colligative properties. Write heading colligative properties. Now see, very important in JEE means we get more questions from colligative properties. Now see, what are colligative property? Property of a solution that depends on the number. So as you know, our Indian country is what? Democratic country. The voting is done on what? Majority of the people, no? So same way, colligative property we call it as democratic property. Means it depends on the number of particles but not on the nature of the solute. Such property we call colligative property. So I repeat, what is colligative property? Property of a solution that depends on the number of solute particles but not on the nature of solute. So write statement definition for colligative. Property of a solution that depends on number of solute particles. But not on what? Nature of solute. So it doesn't depend on the nature of solute but depends on what? How many solute particles are present. Is known as colligative property. Understood, students? So property of a solution that depends on number but not on the nature of solute particles. Now in our syllabus we have 4 colligative properties. So what are those 4 colligative properties important in JEE as well as in NEET? One is RLVP. Now what is the full form of RLVP? Relative lowering of vapor pressure. RLVP is known as relative. That means what we are comparing. Relative lowering of vapor pressure. That is the full form of RLVP. This is one of the colligative property. The second colligative property we are having elevation in boiling point. Elevation. Boiling point gets elevated. Elevation in boiling point. And this elevation in boiling point is shown by the symbol delta TB. Elevation in boiling point we show with the symbol of delta TB. This is the second colligative property, important. There is a third colligative property, depression in freezing point. Depression in freezing point means freezing point, what happens? Get depressed. Depression in freezing point. And this depression in freezing point is shown with delta TF. The symbol is delta TF. The last colligative property, osmotic pressure. Now this osmotic pressure is shown with the symbol of pi. So these are the 4 colligative properties very important in NEET point of view as well as JEE means they are asking questions from relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Copy all these. Now we will discuss one by one of these four colligative properties. Then students, now start writing relative lowering of vapor. We start with RLVP. Now observe here all of you. Relative lowering of vapor pressure. Now before going to RLVPC, let us consider I am taking solvent here. This is of what? A solvent means pure water I took. Now to this solvent I am adding solute to it. Sugar. Assume some sugar I have added to solvent. That makes solution. See, to this solvent I have added sugar. That makes what? A solution. This is solution. See, this is what? A solution we say. Or sugar solution. Now see, now this water will have vapor pressure, no? That is P naught. What is the vapor pressure of this P naught? What is vapor pressure of the pure solvent? And this is also exerting vapor pressure, that is vapor pressure of the solution. Correct? Now if I ask you among the solvent and solution, think over whose vapor pressure comes more. You already studied the concept of vapor pressure, tendency of liquid to convert it into vapor, no? Now if I ask you among pure solvent and solution, whose vapor pressure comes more? Think over. Do solvent will have more vapor pressure or solution will have more vapor pressure? So solution, what happens? See, the solute particles present on the surface, they will not allow the molecules to go into atmosphere. That means to go into outside the glass. Why? Because solute molecules are hindering the liquid molecules to go out. So hence whose vapor pressure comes to be more when you compare solvent and solution? So no doubt vapor pressure of solvent comes to be more. Do you agree? That means vapor pressure of the solvent will always be more compared to vapor pressure of what? Solution. Why? When we add solute to solvent, the solute particles will not allow the molecules to escape. Do you agree, all of you? So hence we can say that vapor pressure of solvent will always be more than. Are you getting idea? Vapor pressure of solvent will be how, student, compared to solution? Will be always more than vapor pressure of solution. Do you agree, all of you? Understood, all of you? This concept is clear, right? Now coming to LVP. Now we are getting a word called LVP. What is LVP? See, lowering of vapor pressure. What is the full form of LVP? LVP means lowering of vapor pressure. Full form is lowering of vapor pressure. Now tell me, student, how do we get lowering of vapor pressure? As we learned, solvent and solution, whose vapor pressure is more? Solvent is more, no? Solution is less. Then how do we get lowering of vapor pressure? It is the difference between vapor pressure of pure solvent to the vapor pressure of solution. Understood? So when we take the difference between vapor pressure of the pure solvent minus vapor pressure of the solution, that will give what, students? LVP. Hence what we define for LVP? P naught minus P. That means it is the difference between what and what? Vapor pressure of the pure solvent to that of solution. So understood? So what we define? So in the exam, when they give vapor pressure of pure solvent and vapor pressure of solution, How do we get lowering of vapor pressure? It is the difference right here, where P naught is vapor pressure of pure solvent. Are you getting idea, all of you? Pure solvent. And what is this P, student? Vapor pressure of solution. So simple, no? So the difference between the vapor pressure of the solvent to that of vapor pressure of solution will give what? Lowering of vapor pressure. Understood, all of you? So copy this. This is important. Now coming to RLVP. Now see, RLVP is what? Relative lowering of vapor pressure. Relative means what? We are comparing with what? Pure solvent. Next slide, relative lowering of vapor pressure. Now observe here. What is this relative lowering of vapor pressure? Simple. It is the ratio between lowering of vapor pressure. What is that lowering of vapor pressure, students? We wrote just now. P naught minus P. Correct? This is lowering of vapor pressure to that of vapor pressure of the pure solvent. That means we are comparing lowering of vapor pressure to whom? Vapor pressure of the pure solvent. That will give relative lowering of vapor pressure. So what we define, it is the ratio. It is the ratio between LVP. What is LVP? Lowering of vapor pressure to that of vapor pressure of pure solvent. Vapor pressure of pure solvent. So pure solvent, what the symbol we show? P naught, no? This is shown with P naught. Then RLVP, mathematically how do we write, students? RLVP is equal to, that is relative lowering of vapor pressure is equal to lowering of vapor pressure, that is P naught minus P. No, this is lowering of vapor pressure by P naught. This is what we call RLVP, relative lowering of vapor pressure. This is important, put star mark and mention the terms here, where P naught is vapor pressure of pure solvent, P is the vapor pressure of solution, P naught is vapor pressure of the pure solvent. Understood, all of you? This is what we define for RLVP, very, very important. Copy this relation. Hope so all of you understood till now what we learnt. When we compare the vapor pressure of pure solvent to solution, always solvent vapor pressure will be more compared to solution. And LVP is nothing but it is the difference between vapor pressure of pure solvent to vapor pressure of solution. And relative lowering of vapor pressure is nothing but it is the ratio between lowering of vapor pressure to the vapor pressure of the pure solvent. Up to this clear, all of you? Copy this relation. And does it have any unit, they ask in exam? Do relative lowering of vapor pressure will have any unit? No, no. As you know, ratio doesn't have any unit. Here mention it has no unit. There is no unit for RLVP. Up to this clear for all? Conceptually understood, no? So what is vapor pressure of solvent? What is vapor pressure of solution? What is LVP? What is RLVP? This is solvent. This water will be solvent. This is solution. By adding sugar to water, we get solution. Copied all of you. Now observe here. Now coming to Raoult's law. We already discussed this Raoult's law at the time of vapor pressure of solid dissolved in liquid, where solid is non-volatile. I taught you once, see the note. Now from that we can derive this relation of Raoult's second law. See what is that relation? See, I am going to the next page. Observe carefully. You remember vapor prayer of right here, vapor prayer of vapor prayer of this we discussed in the previous class of solute of solid. This solid we discussed that it is non-volatile. What is meant by non-volatile? The one that do not convert in vapor like sucrose, glucose, urea present in where liquid, and this liquid is what a volatile. This we discussed in the last class. Now see, very important. What is this? According to Raoult's law, you recollect Raoult what he said. According to Raoult's law, the vapor prayer of the solution, vapor prayer of solution containing non-volatile solute, non-volatile solute is directly proportional to whom last class we discussed. If you are revising, you can understand. It doesn't depend on mole fraction of solvent, depends purely on what? Solvent, because solvent is volatile, no? Is directly proportional to mole fraction of what, students? Mole fraction of solvent, no? Why not solute? Because solute is non-volatile. This we discussed in the last class, recollect. Do we did this or not? Vapor prayer of a solution containing non-volatile solute. The solute is what type of solute? Non-volatile solute is directly proportional to mole fraction of solvent, because solvent is only can vaporize. And this relation mathematically we shown PS is directly proportional to Chi, where Chi is what? Mole fraction of solvent, no? This is vapor prayer of solution. Vapor prayer of solution. And what is Chi? Mole fraction of solvent. Are you getting my point? Mole fraction of solvent. This is what the relation we wrote in the last class. Correct? Now students, what you do? Remove the proportionality. On removing the proportionality, we write PS is equal to P naught. What is P naught? Vapor prayer of the pure solvent into Chi. This relation we wrote in the previous class, recollect, where PS is vapor prayer of solution. And what is P naught, student? Vapor prayer of pure solvent. And what is Chi? Mole fraction of solvent. Here up to this, copy this. Understood? This vapor prayer of solution is equal to vapor prayer of pure solvent into mole fraction of solvent. Up to this clear all of you? Now observe here. Copied everyone, this one, that. Now see, I am going for the next. See. Next. See what is the relation? Vapor prayer of solution is equal to P naught into Chi we wrote. Now what we do? We subtract on both the side with 1. Or what we do? This P naught you bring left side. Then what should I write? Vapor prayer of solution by vapor prayer of pure solvent is equal to Chi we write. Correct? This P naught I brought to left side, student. So vapor prayer of solution by P naught. What is P naught? Vapor prayer of pure solvent is equal to Chi, no? Up to this understood. Now what we do? We subtract both the side from 1. Subtracting both the side with 1. See, I am subtracting both side with 1. 1 minus PS by P naught is equal to 1 minus Chi. Understood? On both the side I am subtracting from 1. Now what will be the LCM? When we take LCM from this, can I write P naught? This is 1 P naught minus PS, student. On taking LCM, what should I write? P naught minus PS by P naught. This is equal to what, student? As we learnt in beginning introduction, chi a plus chi b value is 1 we learnt. So in place of chi b, what should I write? 1 minus chi a. So in place of 1 minus chi a, what I can write? Chi b, no? And this is the second Raoult's law relation, very important. What is this? This we already discussed, no? What is P naught minus Ps by P naught? Relative lowering of vapor pressure of a solution containing non-volatile solute. Now it doesn't depend on mole fraction of solvent. On whom it depends? Mole fraction of solute. So what is the next statement given from Raoult's law? Getting idea, all of you? The relative lowering of vapor pressure, that is vapor pressure of lowering of vapor pressure to vapor pressure of pure solvent will be equal to what? Mole fraction of solute. This is the second statement from Raoult's law. So statement 2 from Raoult, what we write? The relative lowering of vapor pressure. Are you following, students? The relative lowering of vapor pressure of a solution containing what type of solute? Non-volatile solute. Containing non-volatile solute is equal to whom, students? Non-volatile solute is equal to mole fraction of whom? Solute. Mole fraction of a solute. Understood all of you this statement? This was the second statement we can write from Raoult's law, very, very important. Understood, students, from Raoult's law? Actually, Raoult's law, this is what we wrote. From this Raoult's law, we wrote a relation. This is what? P naught minus P by P naught. This is called relative lowering of vapor pressure. So in this relation, in exam, we get numerical in JEE mains as well as in NEET. In the problem, they give you P naught, PS, P naught, and they ask you to find molar mass. How we find molar mass? We will continue this. Copied. Clear. This is very important. The relative lowering of vapor pressure of a solution containing a non-volatile solute is equal to mole fraction of a solute. This is mole fraction of solute. Here, copy. Now see. Now we elaborate this relation. See what I am writing. See this P naught minus PS by P naught is equal to what we wrote chi B, no? Now what is mole fraction of solute? You are familiar in introduction. How you get mole fraction of solute? This can be further elaborated as P naught minus PS by P naught is equal to mole fraction of solute. How do we write, students? Number of moles of solute upon number of moles of solute plus number of moles of what, student? Solvent, no? We learnt in the introduction mole fraction. Are you solving questions from solution, everyone? So this is what in place of chi B we are introducing number of moles of solute by number of moles of solute plus solvent. Or we can elaborate this P naught minus PS by P naught. This moles, how you get moles? Mass by molar mass, no? So I am writing with a small w by small m. See, small w, small m is meant for solute by mass of number of moles of solute. What should I write? Small w by small m. Whereas to differentiate solvent, I am writing with capital W by capital M. Getting idea? See, for solvent, I am showing to differentiate capital W by capital M. This is the extended form of Raoult's law. Very important, where P naught is vapor pressure of pure solvent, PS is vapor pressure of solution, and W is weight of solute, small w, small m is molecular mass of solute, and capital W is weight of solvent, capital M is molar mass of solvent. Write the terms right here where P naught is vapor pressure of pure solvent. And what is PS? Vapor pressure of solution. And what is small w? Small w is mass of solute, that is weight of solute. See the differentiation I wrote with capital W, capital M is capital W, capital M for solvent, weight of solute. What is small m? Molar mass of solute. And capital W is what? Weight of solvent. And capital M is molar mass of solvent. Copy this. So in this relation, we get numerical in JEE mains as well as in NEET. So what is this? They can ask you to find molar mass of solute. Copy this. Understood up to here, all of you? Very important. Raoult's law. That is RLVP we say. Relative lowering of vapor pressure. Done, student? Now observe here. Now see here, let us consider the solution to be dilute. What is meant by dilute solution? Consider solution is dilute solution. Dilute means what, student? Dilute means very less amount of solute is present. Dilute solution we write. Let us take solution is dilute. Now what is the relation we took? That means number of moles of solute will be very less compared to whom? Number of moles of solvent. Assuming solute is very less amount than compared with solvent. Now what is that relation we wrote? We can write now, see what is that? P naught minus P by P naught is equal to what we wrote? Small w by small m by, and since solute is negligible, see, as solute is negligible, I can write only capital W by capital M. Means whom I am neglecting? Number of moles of solute is negligible, is very less than 1. So if the solution is dilute, if you say, then what you do? You condense that. Then what we get? P naught minus P by P naught is equal to this small w, capital M goes to numerator, no? Then capital M by what we write? Small m into capital W. This is simplified Raoult's law. This relation what we call simplified. Why? We are assuming the solute to be dilute. Solution to be dilute. Right here, this is simplified Raoult's law. This already we wrote, no? Where small w is weight of solute, capital M is molar mass of solvent, and small m is molar mass of solute. Capital W is weight of solvent. Assuming the solute to be dilute. If it is dilute, we have to eliminate moles of solute in the denominator. Understood? This is what RLVP, the first colligative property. With this RLVP completed. Any doubt in this? Till this understood, everyone? So till now we studied what is RLVP, what is LVP, what is RLVP. Then we wrote relation Raoult's law. This Raoult's law, from this Raoult's law we derived the relation P naught minus Ps by P naught is equal to chi b. Now write one problem, one question you write. 30 grams of urea. Urea, you know, no, it is used in fertilizer. What is the formula of urea, students? NH2 CONH2. This is urea. It is a non-volatile solute. E is present in 45 grams of water. So water is solvent. 45 grams of water solvent at a given temperature. At a given temperature. At a particular temperature, this is what we dissolve. And its P naught, what is vapor pressure of pure solvent water is, this is vapor pressure of pure solvent water is 300 mmHg. What is millimeter of Hg? Then find, I want 5 parts from this. Then find first part. I want first part vapor pressure of solution. That is PS. Second part I want LVP. What is LVP? P naught minus P. That means once I get PS, we can get LVP, no? The third part I want RLVP. What is RLVP? Just now we studied ratio. That is LVP. After getting this P naught minus P by P naught we have to find. The fourth part I want mole fraction of solute. What will be mole fraction of solute? The sixth part I want mole fraction of solvent. Mole fraction of solvent. The seventh part I want molality. Important in exam. Molality, you remember in the introduction we studied number of moles present in 1 kg of solvent. Now 6 parts I want from this question. Think over how you find PS, LVP, RLVP, mole fraction of solute, mole fraction of solvent, molality. Now from Raoult, you remember what the relation we wrote from Raoult's law, student? We wrote that vapor pressure of solution is directly proportional, is equal to P naught into chi A. For a non-volatile solute, recollect, vapor pressure of solution is equal to P naught into chi A, no? Now vapor pressure of solution we want, students. So PS is equal to, had you given vapor pressure of the pure solvent, see 300 given, into mole fraction of solvent. How you get mole fraction of solvent? This is solvent. Number of moles of solvent by number of moles of solute plus number of moles of solvent. No? Getting idea? Now had you given moles of solvent to you directly? No, mass given. How many grams? 45 grams is solvent weight and solute mass is 30 grams. So what you do? PS is equal to 300 into. Now how you get moles of solvent? Mass is given how many grams? 45. What is the molar mass of water? Solvent is water, no? Molar mass of water is 18 upon this 45 by 18 plus what is the mass of solute given? 30. And urea molar mass, if you find out this, you get 60. Check nitrogen 14 into 2, hydrogen 4, carbon 12, oxygen 16. This is to be divided with 60. Now find out any cancellation. 3 multiple will cancel. 3 6 are 18, 3 15s are, 3 2s are, 3 5s are. Is it coming 5 by 2 in the numerator? And denominator also 5 by 2. And any cancellation, 30 will cancel by 2. So I am writing here, then PS of the solution is equal to 300 into 5 by 2 and LCM for 5 by 2 plus 1 by 2. 5 by 2 plus 1 by 2, then PS is equal to what you write, 300 into 5 by 2. The LCM for this will be 2. So 5, this is 1, this is 6 by 2. So PS is equal to 300 into 5 into 2 by 2 into 6. This 2 get cancelled. Then 300 ones are, 300 twos are. 2 will cancel by 50 times. So 50 into 5 comes how much? 250. This 250 will be in what unit, student? mm of Hg. What is mm? Millimeter of Hg. Now this is what vapor pressure of solution we found from Raoult's law. Understood? So vapor pressure of solution is 250 Hg. Clear? Now think over second part. Second part already we found PS. This is 250 and P naught of the solvent given 300. So how you get difference between solvent minus solution? That is 300 minus 250. That comes how much, student? 50. Unit will be mmHg. Check, is it coming, everyone? 50 mm of Hg. Second part should be 50 mm of Hg. Clear? Now RLVP, it is ratio. This we found 50, no? So this 50 is to be divided with vapor pressure of the pure solvent. That is how much? 300. So 0 cancel, 5 ones are, 5 6 are. When you simplify it, how much it comes? 1 upon 6. That 6, what will won't go? 6 1 6 4 0 6 6 are 36. It will be bar. That means it is coming how much? 0.166. This will be the RLVP. Understood? Now, what will be mole fraction of solute according to Raoult's law? P naught minus P by P naught is equal to mole fraction of solute, no? So already RLVP we found. Can I say it will be same as mole fraction of solute? So no need to calculate, 0.166. Understood? Then mole fraction of solvent I can get how? Since chi A plus chi B is equal to 1, no? So how I get 1 minus 0.166? Getting idea? Sum should be 1, no? So from 1 subtract 0.166. 1 minus 0.66. 0.166. Sorry. This comes 10 minus 6 4, 9 minus 6 3, here 9. Is it coming 0.934? This will come 0.934. Now another part we have to find molality. In the previous class we wrote a relation. Copy this up to this. We wrote, if you remember, mole fraction of solute is equal to molality by molality plus 55.5. We wrote a special formula. Recollect molality. Do you recollect, students? Molality is equal to mole fraction of solute is equal to small m by small m plus 55.5 if it is water. Till this copy it. Understood, everyone? So simple, no? This is from Raoult's law. See, 5 parts we are finding: vapor pressure of solution, relative lowering of vapor pressure, lowering of vapor pressure, and RLVP will be equal to same as water, mole fraction of solute. Theorem. Now first last part we have to find molality. Now see, molality, to get what is the relation, we wrote mole fraction of solute is equal to molality by molality plus 55.5. This we wrote in the introduction class. If you can check your notes. Mole fraction of solute, how much we got? See, previously mole fraction of solute we found The mole fraction of solute is 0.166. So now substituting that 0.166. 0.166 is equal to molality by molality plus 55.5. This you find out, you can write this as 1m is equal to cross multiply 0.166 m plus 55.5 into 0.166. And from this find out molality, you get small m. Do the calculation that 0.166 plus this entire thing you have to multiply 0.166 into 55.5. From this find out molality. This is the relation from molality. So with this all 5 parts we did. Understood all of you? So what are those? One is vapor pressure of solution, LVP, RLVP, mole fraction of solute, mole fraction of solvent, and molality. Clear? Now write one more problem. Write one more problem. 30 grams of non-volatile solute. 30 grams of non-volatile solute is dissolved in 360 grams of water. 360 grams of water at 100 degrees Celsius. See here important temperature given 100 degrees centigrade and vapor pressure of the solution. Vapor pressure of solution is 570 mmHg. Is 570 mm. What is mm, students? Millimeter of Hg. Then find the molar mass of solute. Then find the molar mass, molecular mass of solute. Assuming solution to be dilute. Assume the solution is dilute. Means you can neglect the denominator. Now this is a question from Raoult's law. See carefully, mass of solute given 30 grams. This has been dissolved in 360 grams of water at 100 degrees Celsius. There is one hint here, 100 degrees Celsius, very important. And the vapor pressure of the solution given to you, 570. Then what will be the molar mass of the solute is asking. So then what the relation, Raoult's law, P naught minus P by P naught, that is equal to, since we are assuming dilute, so small w by small m, we are neglecting the solute in the denominator, capital W by capital M. Now students, here P naught is not given in the problem. But water boils at where? Atmospheric pressure, no? What is the boiling point of water? 100 degree. At boiling point, vapor pressure will be equal to 1 atmospheric pressure, no? So indirectly, P naught is indirectly given 1 atmosphere. Getting idea what I am saying? That means you have to take here how much. This is in mm, no? And conversion factor you have to know in states of matter you studied first year. 1 atmosphere is equal to 760 mm of Hg. This will be 760 mm of Hg. That means indirectly he has not given P naught. So here what should I take? 760 minus vapor pressure of solution after adding. This is the vapor pressure of solution, 570 by 760. This is equal to mass of solute given 30 grams. So 30 by molar mass we have to find out. This is unknown. By how many grams of solvent? 360 grams of solvent, and molar mass of water is 18. Now from this we have to find molar mass of this solute. What will be the difference of 760 minus 570? Subtract this. This comes from 16 minus 7, 9, and here 190. Correct? So this 190 upon 760 is equal to 30 into 18. This 18 goes to numerator by molar mass into 360, assuming the solution to be dilute. Now any cancellation, 0, 0 get cancelled, and see any cancellation, 3, the 0, 0 I am cancelling, and 3 ones are, 3 ones are, 3 twos are, 3 fours are, 3 six are, 2 twos are, 2 threes are. Then what will be the m? M is equal to molar mass is equal to 76 into 3 upon 19. Correct? This on simplification, 70 m is to be found now, 76 into 3 upon 19. Now any cancellation, this one 3, 7, 19, 3, 19, 4 nines are 4 nines are 36. So 4 times it will cancel. Correct? 4 nines are 76, 4 nines are 36, 7. This will cancel by 4 times. So 4 into 3, what will be the molar mass? 12 gram per mole. This will be the molar mass of solute. So these many grams is present in 1 mole. So this is what from Raoult's law. See, this is important. Whenever atmospheric pressure 100 degrees centigrade given, it is to be known water boils at 100 degree. At that atmospheric pressure we have to consider. Understood, friends? So with this RLVP completed. What is RLVP? Relative lowering of vapor pressure. Clear, students? Are you following, everyone? And see, I told you on the day what we teach, you have to recap at home. At a hostel, you people are there. So the content what we are teaching here, you have to understand and you have to work on that. Then only you know whether you are following or not. So regularly you have to come and see the concepts, understand the concept carefully. And all these are important. Solution chapter, electrokinetics are numerical chapters, weightage chapters they are. And easy scoring in this. But daily I told you, 20 questions, 20 to 25 you have to work on that. Understanding the and material you might be they given to you that from PW material you solve the questions till now what we done. So don't keep pending at the time of when we start from June. So by that time you complete all that daily 25 questions from the till the topic what we completed. Okay, I am ending the session. Time up. Tomorrow we will discuss elevation in boiling point, depression in freezing point, osmotic pressure. Okay, students. So wish you all the best. I am ending the session. Bye.